Over the years, technology has revolutionized our world and daily life. This also created a future change in driving technology. A person had to be in control of vehicle movement, from a horse-drawn cart to a motor car. Traveling is required time and concentration. This human operation is interface and the computer will take its place. This is a documentary about the autonomous of driving technology. In the past 5 years, autonomous driving car has gone from possible to definitely possible and now commercially available. Now, are you wondering what is actually meant by autonomous driving technology? A driverless car uses a combination of sensors, cameras, radar and artificial intelligence to travel between destinations without a human operation. There are actually 5 different levels of automation. It's meant that your car capable of sensing its environment and operating without the human involvement. Once you arrive, your car will even park itself. Now, we move to the history of autonomous driving technology. In 1939, Norman Bell Gates created the first self-driving car. In 1958, General Motors had made this concept a reality. While in 1977, the Japanese Tsukuba Mechanical Engineering made some improvement. Next, in 1987, 2 of Germany's leading car manufacturers collaborated on a project called VAMOS. The VAMOS was a 5-ton Mercedes-Benz van. This technology was a big leap from Japan.
Heading towards an era, the technology of car will be more advanced. So, that's how autonomous car is created. Basically, the technology used in autonomous driving car is from the Intelligent Transport System, ITS. It is based on wireless technologies, which are the communication between vehicle to vehicle, V2V, and vehicle to infrastructure, V2I. It obtains information on everything from accident ahead, slippery road condition, and parked cars to the speed of the other vehicle and pedestrian, and process those information exponentially faster than human drives. Autonomous car involves an autonomic driving system that doesn't need a physical driver because the car can control it by itself. So the main question here is, how does those technologies work on car? Is it successfully or fail? Basically, the autonomous car rely on sensors, actuators, complex algorithms, machine learning system, and power processors to execute software. So why do the car need all of this? Firstly, it can create and maintain a map of the surroundings based on a variety of sensors which located in the different parts of the car. Secondly, the radar sensors monitor the position of nearby vehicles so that it can avoid a collision between the car. By this, it can help to reduce the number of accidents happening year by year. In addition, the video cameras can detect traffic lights, read road signs, and track other vehicles. It is also a lookout for pedestrians and other obstacles. Next, the light detection and ringing, which is also known as the LiDAR sensors, bounce pulses of lights off the car surroundings. It is to measure distances between the cars, detect road edges, and also to identify lane marking. On top of that, the car contains ultrasonic sensors which is located in the wheels that can detect the position of the curbs and other vehicles when parking. So this advanced software then processes all the sensory input, then plots a path and sends the instruction to the car's actuators, which can control acceleration, braking, and steering.
Do you know there are 5 levels of automation? Now, let's understand each level of autonomous vehicles. Level 0. No automation. At this level, there are no autonomous features in the car. Each of the driving action is performed manually by the human driver. The car may be automatic, but they are not autonomous. Example for this level is this old Ford Mustang. Level 1. Driving assistance. Most of the vehicles on the road are at level 1, which widely used without automation. The driver has full control over the speed, accelerator, brakes, and steering wheel. However, the vehicles can assist the driver in a certain situation only. Example for this level is this Audi A7. Moving on to the level 2. Partial automation. At level 2, vehicles have more driving assistance compared to the previous level, like adaptive cruise control, parking line detection, and autonomous emergency braking. But the driver are advised to remain in control of the car and pay attention to the traffic. Example for this level is Tesla Autopilot. Level 3. Conditional automation. In this level, the vehicles are under complete control and all the primary function is under responsibility of autonomous system. This includes detecting certain traffic and weather condition. If the system are unable to control or unsuitable with the current condition, it will inform the driver to take control of the vehicles. Example for this level is Audi Traffic Jam Pilot. Level 4. High automation. At level 4, no assistance from the driver is required. Vehicle can fully perform all the main driving function, but may require the human intervention from time to time. However, high automation is limited to specific geographical area where the vehicles are compatible to the condition. Example for this level is Waymo Firefly. Level 5. Full automation. At level 5, the vehicle does not require the human driver at most conditions. The basic control elements such as the steering wheel or pedals are no longer needed. At this moment, the car actually drives by itself wherever the owner wants. It simply can react as the human driver, all would be better. Example for this level is Audi Icon.
The advantages of autonomous driving technology. Decrease and lower the number of accidents. 57% of British and American roadway accidents are due to human error. Humans are prone to interruption. By having an autonomous cars, it will help to prevent human error from happening as the vehicle is controlled by the system. Stress-free parking. Parking will be a lot quicker, less stressful, and require no special skills, especially parking places that are small and narrow. Thus, it will allow the car to directly move to a detected vacant parking spot. Next, accessible to all legal age drivers. Sensory technology could potentially perceive the environment better than human could, seeing farther ahead, better in poor visibility, and detecting smaller and more subtle obstacles. Thus, it will become easier and safer, especially for senior citizens, disabled people, and new drivers. Last but not least, reduce traffic jam. Individual driver behavior are one of the factors that can lead to high traffic congestion. Severe accident and road rage also contribute to traffic jam. Autonomous driving technology, able to make the traffic more efficient and systematic, also prevent any unwanted accident. Introducing to you the B-segment SUV Proton X50, the first car in Malaysia that features a suite of advanced driver assistance system, ADAS, which can be categorized as the level 2 of autonomous driving technology. This particular model was launched in Malaysia on 27 of October 2020. According to the level of driving automation stated by the Society of Automotive Engineers International, the two main functions that qualifies the X50 as the level 2 of autonomous driving technology is the intelligent cruise control and the auto park assist. Intelligent cruise control. Intelligent cruise control will encompass Proton X50 with longitudinal control, by adaptive cruise control to maintain the safe distance from the vehicle ahead based on the preset cruise control speed that is ranged from 30 to 150 km per hour. It also equipped Proton X50 with lateral control by lane keep assist to actively keep vehicle in the center of the lane. It also will provide audio-visual warning that is activated when hands-off driver detected. The next function of Proton X50 is Auto Park Assist, an intelligent and convenient self-parking system to help you ease into parking spot. It will actively control the steering, throttle, brake, and gear shift. This APA system also includes the vertical parking, parallel parking, and parallel parking out.